NASA indefinitely delayed the return flight of two astronauts on Starliner, but continues to assert that this is not a stranded situation. So we got to ask, is that actually the truth? Indeed, Boeing Starliner is getting worse than we think. Let's find out more in today's episode of Alpha Tech. So on June 5th, the crew flight test CFT mission of Boeing CST-100 Starliner spacecraft completed its first stage successfully, sending two astronauts to the ISS. However, the return process did not go as smoothly. In a statement on June 18th, NASA said that the event of bringing astronauts back to Earth would occur after the second of the two planned spacewalks at the space station that was scheduled for July 2nd. That spacewalk has since been postponed to late July after a water leak from a suit umbilical line in the airlock just as a June 24th spacewalk was beginning. That spacewalk got scrubbed. This has led to the Starliner's test flight schedule getting extended by at least a month and a half and possibly longer. On the afternoon of June 28th at a press conference, NASA explained that the additional delay is to conduct ground tests on the Starliner's RCS thrusters to try and replicate the conditions that caused the thrusters to malfunction during the approach to the station. These tests, expected to start this week, are going to take a few weeks. Steve Stitch, NASA Commercial Crew Program Manager, noted that these ground tests would also allow for a detailed examination of the thrusters to determine the possible causes of the issue, something that cannot be done with the thrusters in space on the Starliner. These thrusters are located in the spacecraft service module, which is discarded and burns up in the atmosphere, making post-flight study impossible. This will be the real opportunity to examine the thruster just like we had in space on the ground, with detailed inspections, he said. Doing those tests now, rather than after Starliner returns, gives spacecraft controllers the options to do additional thruster tests on Starliner before undocking and to get as much data out of the spacecraft before it leaves home. We understand these issues for a safe return, said Mark Nappy, Boeing's vice president and commercial crew program manager of the thruster and helium leak problems at the most recent briefing. But we don't understand these issues enough for us to fix them permanently. Officials said there was no rush to bring Starliner with Wilmore and Williams on board back home. There were plenty of supplies on board for the two, along with work for them to do at the station. We had the luxury of time, said Ken Bowersox, NASA's associate administrator for space operations, said at the briefing. At this point, the spacecraft's technical issues have turned into a scheduling problem. Initially, when Starliner was introduced, the CFT mission was expected to take 8 days at the ISS. Although it could be potentially extended by a few days or weeks if necessary, experts at the time said the spacecraft could stay at the station for up to 45 days, based on the battery capabilities of the crew module. However, the return date to Earth has been continuously pushed back, each time by 4 days. This is mainly due to the landing conditions required for Starliner at sites in the southwest U.S. The first 4-day delay was to avoid conflict with a previously scheduled spacewalk. Other delays are believed to be related to technical issues with Starliner itself. And due to those prolonged delays, NASA is now reconsidering the 45-day limit previously set for Starliner. In a recent meeting, Mr. Stitch shared that so far the batteries have not shown any signs that would limit performance or add additional risk if the mission extends longer than planned. The risk for the next 45 days is essentially the same as the first 45 days, so we'll go update that limit, he said. But the series of delays in Starliner's return, with now an indefinite return date, have created a narrative that Williams and Wilmore are stuck and stranded in space. To cite two words commonly used in media reports in the last couple of weeks across the world. Stitch said at the start of the June 28th briefing that he wanted to clear up those misunderstandings. I want to make it very clear that Butch and Suni are not stranded in space. Our plan is to continue to return them on Starliner and return them home at the right time. Got a little bit more work to do for their final return, but they're safe on the space station. Their spacecraft's working well and they're enjoying their time on the space station. Nappy, a little later in the briefing, turned from clearing up misperceptions to airing complaints about media coverage he gets daily about the mission. Every morning I sit and read him, and I tell you, from being a representative of Boeing and a representative of the Starliner program, they're pretty painful to read, he said. We've gotten a really good test flight that's been accomplished so far and being viewed rather negatively. This situation sparked a strong reaction from the press during the meeting. They criticized NASA and Boeing for the lack of transparency about the mission and demanded more frequent and detailed updates. Example: NASA primarily posts updates on its blog. However, since June 14th, the initial expected end date of the mission, only 3 updates have been published. The continuous delays without specific explanations for the causes and the final deadline make the public feel like they're witnessing a moving of the goalposts without an end in sight. This lack of transparency has led to concerns about the safety of the Starliner when returning to Earth. Although officials assert that Starliner could be used to bring Wilmore and Williams back in an emergency, they've been cautious, whether intentionally or inadvertently, about its ability to return under normal conditions. At the end of the meeting, NASA promised to provide more frequent updates on the mission, especially during the thruster inspections. However, they did not make any specific commitments regarding this. There will be time later for more discussions about the long-term future of Starliner. Nappy at Friday's briefing bluntly rejected the suggestion that Boeing would give up on the program after this test flight. The plain and simple answer to the question is no, we're not going to back out. This is our job, and that's what we're going to continue to do to meet our commitment. Even the head of the Indian Space Agency, ISRO, which has zero involvement in the Starliner CFT mission, was asked to comment on the situation given the interest in the country linked to Williams and her Indian heritage. Getting stranded or stuck in a place is not a narrative that we must have in a moment, as Samant said. The question today, when we develop a spacecraft like the Starliner, should be whether it can operate reliably for onward and return journeys. This, I believe, is what agencies concerned are thinking. However, the issues might mean that Starliner will not be ready as previously planned for the first crew rotation mission to the station, Starliner 1, in early 2025. NASA had anticipated that when Starliner was preparing for launch in May, it would have a certified vehicle in November to carry out those missions, alternating with SpaceX. Stitch stated that during the call that certification would take longer than expected, but didn't say that Starliner would not be certified in time for the early 2025 mission. At some point, NASA's going to have to decide whether or not to continue with those plans or move SpaceX's Crew 10, currently scheduled for late summer 2025, to an earlier launch in early next year. He mentioned that NASA is working in parallel on both Starliner and Crew 10, giving the agencies some schedule flexibility. We can take our time and get through the crew flight test and have the vehicle return with Butch and Suni, and then we can make decisions afterwards, he said. We still have time. But as many recent recommendations suggest, NASA and Boeing should choose Dragon as the backup vehicle if Starliner's condition deteriorates in the future. The Boeing Starliner was initially heralded as a beacon of innovation in space travel, promising to revolutionize NASA's commercial crew program. However, the program quickly encountered significant obstacles that undermined its ambitious goals. Technical setbacks plagued the development and operational phases, resulting in numerous delays and increased costs. Safety concerns also emerged, with critical issues that compromised the spacecraft's reliability. Ultimately, these challenges have eroded confidence in Boeing's ability to deliver a safe and reliable spacecraft. Continuing the series of delays for the Starliner, NASA and Boeing managers have once again decided to extend the Starliner crew's stay at the ISS, bypassing the re-entry date of June 26th. Previously, the Starliner had other delays on the 18th and even on the 22nd. This latest delay marks an indefinite postponement of Boeing Starliner's return to Earth, marking another major setback for the troubled test flight aimed at competing with SpaceX's Dragon crew. Now, NASA and Boeing's engineering team will need more time. Sources indicate that NASA considers June 30th now as a possible return date, but the agency also wants to conduct a few spacewalks currently planned for June 24th and July 2nd will now continue. The Starliner will return to Earth afterward, possibly no earlier than the 4th of July holiday. We are strategically using the extra time to clear a path for some critical station activities while completing readiness for Butch and Suni's return on Starliner and gaining valuable insight into the system upgrades we will want to make for post-certification missions, Steve Stitch, manager of NASA's Commercial Crew Program, said. In some key respects, keeping the NASA Starliner docked at the space station for a longer period will be beneficial for NASA and Boeing. They can collect more data on the vehicle's performance during long-term missions. Ultimately, the Starliner will conduct operational missions, allowing astronauts to stay in orbit for 6 months at a time. However, the vehicle is currently rated for a 45-day stay on the space station, and that clock started ticking on June 6th. Moreover, NASA's continued need to delay the vehicle to be comfortable with its performance is not optimal for its return journey to Earth. In several press briefings since Starliner docked with the station, officials have downplayed the overall severity of these issues, repeatedly saying that Starliner could return home in case of an emergency. But they have yet to fully explain why they're not comfortable with letting Starliner fly back to Earth under normal circumstances. If an unforeseen circumstance arises, even with propulsion system issues, NASA asserts Starliner retains the capability to safely return astronauts to Earth if necessary, whether serving as an emergency escape vehicle from the ISS or if any Starliner components like solar panels show signs of premature failure. Steve Stitch said given the extended duration of the Starliner mission, it is appropriate for us to complete an agency-level review, similar to what was done ahead of NASA's SpaceX Demo 2 return after 2 months on orbit, to document the agency's formal acceptance on proceeding as planned. He was referring to the first flight of astronauts aboard SpaceX's Crew Dragon ferry ship in 2020. But the Demo 2 mission did not experience problems like the ones noted so far in the Starliner's first piloted test flight. In contrast to Starliner's current mission schedule uncertainty, NASA did not set a specific return date for its Crew Dragon astronauts mission in 2020, ultimately extending 62 days due to astronauts needing to aid ISS maintenance during a period of understaffing. So, what if Starliner proves unusable? If deemed incapable of returning Butch Wilmore and Suni Williams, a fallback option would involve returning them home aboard Crew Dragon, which transported 4 astronauts to the station in March and could accommodate additional passengers in case of an emergency. Such a scenario, considered unlikely, would undoubtedly pose a dilemma for Boeing. However, NASA and Boeing officials, along with program-savvy engineers, have not indicated current Starliner issues necessitate this step. In such a scenario, Starliner's fate would hinge on various factors, including the severity of technical challenges. SpaceX's Dragon, on the other hand, stands out. SpaceX has established itself as a pillar of reliability in the aerospace sector, particularly excelling in the safe transport of astronauts during both routine and critical missions. The company's reputation for dependability in astronaut return missions is built on a foundation of consistent success with its Falcon 9 rocket and Crew Dragon spacecraft. With over 300 successful Falcon 9 launches, SpaceX has demonstrated unparalleled proficiency in both cargo and crewed missions. The Crew Dragon, developed under NASA's Commercial Crew Program, has repeatedly proven its worth through multiple successful missions to the ISS. These achievements underscore SpaceX's ability to meet and exceed NASA's rigorous safety and operational requirements, whether for ISS resupply missions or crew rotations. SpaceX's capabilities truly shine in emergencies. A prime example occurred in December back in 2022 when a Russian Soyuz spacecraft suffered a critical coolant leak while docked with the ISS. With concerns mounting over the Soyuz's ability to safely return its crew, NASA turned to SpaceX's Crew Dragon as a potential lifeline. Rising to the challenge, SpaceX swiftly launched a Crew Dragon atop a Falcon 9 rocket. The spacecraft successfully docked with the ISS and, following stringent safety protocols, safely returned the stranded astronauts back to Earth. This incident not only highlighted SpaceX's technical prowess, but also its ability to respond effectively under intense pressure, further cementing its status as a go-to provider for critical space operations. Therefore, NASA and Boeing officials are urged to quickly review the replacement mission to rescue and ensure the safety of 2 astronauts stranded in space by the Starliner. The successive failures with the Starliner capsule are indeed more serious than anyone had anticipated. The initial crewed launch, scheduled for May 6th, was abruptly canceled due to a malfunction in the valve of the Atlas V rocket. This valve, crucial for regulating pressure in the upper stage, was found to be defective, necessitating a last-minute halt of the mission. Following this, the launch was scheduled for June 1st, but faced another critical issue just minutes before liftoff. A computer card malfunction in the ground launch sequencer caused an automatic hold, highlighting yet another technical flaw that needed immediate attention. Engineers identified a problem with the power supply unit in one of the ground control computers, which required replacement before any further attempts could be made. Despite these initial setbacks, Boeing managed to successfully launch the Starliner on June 5th from Cape Canaveral Space Force Station. The spacecraft, carrying veteran astronauts Butch Wilmore and Suni Williams, docked with the International Space Station on June 6th. However, this success was short-lived as ongoing technical issues continued to plague the mission. The Starliner's propulsion system experienced helium leaks, a critical problem that necessitated further investigation and repairs. These leaks compounded the delays, pushing back the spacecraft's return mission multiple times. The persistent technical difficulties and inability to fully understand and rectify the underlying problems have left Boeing in a precarious position, highlighting the significant challenges faced by the Starliner project. The issue goes beyond technical aspects. It also reflects deeper troubles in the decision-making and management processes of Boeing's and NASA's Starliner programs. The launch has already been delayed once due to a similar problem, indicating a troubling pattern of recurring technical failures. The decision to launch, despite known issues, revealed a critical underestimation of the spacecraft's vulnerabilities and raised serious questions about the program's risk assessment protocols. Steve Stitch, NASA's commercial crew manager, defended the decisions, citing a data-driven approach. However, this justification failed to address the fundamental reliability concerns plaguing the Starliner. The recurring technical failures and their mishandling pointed to systemic flaws in the program's management and operational oversight. These events further complicated Boeing's efforts to establish the Starliner as a viable alternative for NASA's crewed missions. To address these difficulties, Boeing's Starliner will face stricter scrutiny and greater challenges in regaining the trust of NASA and the public in the coming period. For NASA, the challenges of Starliner are strategically significant, especially as it currently relies on SpaceX's Crew Dragon. If Boeing overcomes these obstacles, the company could reclaim its position, providing NASA with a diverse portfolio of commercial crew vehicles and enhancing mission planning flexibility. Ultimately, a successful Starliner program would contribute to a stronger and more competitive commercial space sector, benefiting NASA by reducing reliance on a single provider, fostering innovation, and ensuring continuous access to the ISS. Boeing, as a manufacturer, has become a mess over the last 2 decades, struggling with the technical failure of its Starliner spacecraft on the ISS. As the pressure mounts, attention is shifting towards SpaceX as a potential solution to this crisis. However, no definitive decisions have been made yet as to who will rescue Starliner, whether it will be SpaceX's Dragon or something else. SpaceX to rescue Starliner? Why not? Starliner, launched on June 5th, is currently docked at the International Space Station on an indefinite mission. NASA and Boeing officials maintain that the spacecraft is in good condition and can leave the ISS in an emergency. However, both NASA and Boeing are trying to understand why some of the reaction control system thrusters on Starliner failed during the docking preparation with the ISS June 6th, and why some helium leaks appeared in the spacecraft's compartment. Because of this, Starliner will remain in space until at least the end of the summer as tests and analysis continue. This means astronauts brought up by Starliner have to stay on the ISS beyond their originally allocated days. NASA officials acknowledge that they might be there for a total of 90 days, 9 times longer than the mission's planned 10 days. However, it might even be longer since, after all, NASA has stated that Starliner has been evaluated to stay in orbit for 210 days once operation missions begin. Remember that flying into space is an extremely complex challenge, especially with manned flights. That's why NASA is striving to collect more data throughout this test process. Testing on June 15th in orbit was unable to find the root cause of the issues, although agency officials stressed on June 28th that progress has been made. The helium leaks have stabilized, and all but one of the errant thrusters is rated for use to come back to Earth. Starliner has 28 thrusters altogether in its RCS. 5 were misbehaving, and of those 5, only 1 will be taken offline during undocking. Repairs and testings continue in the coming days. Stay tuned for the latest updates from NASA about this. However, what if these tests fail to improve the Starliner? Well, they still have to rely on SpaceX. Although NASA and Boeing officials have reiterated that the current issues on Starliner do not indicate that SpaceX needs to assist, the Crew Dragon can still complete the mission. Scott Walter, who has a doctorate in mechanical space engineering, noted that nothing's off the table, suggesting that NASA's already spoken with SpaceX about a potential rescue mission, and the private Polaris Dawn spaceflight next month may also be a part of the agency's Plan B. Michael Lembeck, an aerospace engineering associate professor at the University of Illinois Urbana-Champaign, said that NASA and Boeing are just doing their homework. It's too early to cause the root cause of the problem, said Lembeck, who was a consultant for Boeing's spaceflight division from 2008 to 2013. He continued to explain that keeping Starliner docked at the ISS is the only way to study the capsule fully. I would think that NASA is considering all contingencies well in advance, said Walter, who's the chief technical advisor for Visual Components North America. They've already thought these scenarios through if one of these capsules gets stranded or something goes wrong. They aren't suddenly scrambling to figure this out. He continued to explain that NASA and SpaceX have likely had a discussion behind the scenes about using the Dragon capsule. I think there is a Polaris Dawn mission with Jared Isaacman, which could potentially be turned into a rescue mission, Walter added. I am sure he would gladly say go ahead. Isaacman had funded the Polaris Dawn mission set to launch July 31st, which will see the first commercial spacewalk. As far as I know, Starliner's fine to come home, but if they gave up on that vehicle, then I realistically think NASA would just send Crew 9 up with 2 crew members, he said. The complexity and challenges associated with the developing and operating manned space vehicles are indeed very high. Every decision must be carefully weighed between collecting valuable data and ensuring the safety of the crew and assets. In fact, NASA has never had any rescue missions in space. To be honest, this is a very feasible scenario that NASA might face in the future. It needs to be explored and understood as humanity continues to advance in space. One only need look back to the Apollo 13 in 1970 to see the types of conditions that can occur with astronauts needing rescue. The 3 astronauts on the mission encountered an extremely dangerous situation when one of the 2 oxygen tanks exploded in space, turning the mission from a moon landing to a simple survival task. Their lifeline was ultimately the lunar module, which was connected to the command module, giving the astronauts a chance to return safely with the backup spacecraft. America has the obligation, ingenuity, and technological sophistication to ensure the safe return of all humans to Earth. ISS is now in its 25th year in low Earth orbit and has hosted over 270 astronauts. Meanwhile, China's Chang'e space station was completed in November 2023 and currently hosts 3 talconauts. Elsewhere, Virgin Galactic and Blue Origin have sent several space tourists and astronauts to low Earth orbit for short missions, and we will soon see humans returning to the moon and beyond. With these rapid developments in commercial space travel, you would expect a space rescue to be a top priority. In fact, this is an urgent issue, according to Shauna Penda, Director of Space Medicine Group at the International Institute for Astronautical Sciences. Pena argues that we're getting closer to being too late if we don't act immediately. When you start thinking maybe we should stop thinking about this, it means you are rapidly approaching the event horizon of that tipping point, and you are about to enter a phase of exponential growth, after which it will be extremely difficult to try to catch up, Pena said. The reality is that space companies have hardly any plans for space rescue. Pena wrote a report in October 2023 titled Safety and Rescue in Manned Space, Where Are the Gaps? The report looks at various aspects of rescue operations, including preventative measures, contingency planning, active rescue, and autonomy for self-rescue. Pena divides rescue operations into 3 categories: preventative measures and contingency planning, such as having backup vehicles available for deployment in case of disaster, active rescue capabilities like lifeboats or shelters in case of debris collision, and the autonomy and self-rescue capabilities of astronauts, on-the-spot repairs, prediction, and detection to enable astronauts to mitigate risks. However, the core issue is that there are some gaps in the existing frameworks. Currently, there are no binding international missions on space safety and rescue, a lack of regulation for commercial flights, threats related to deep space missions, a lack of medical evacuation for transit and operations on Mars, etc. Moreover, since many launches today are operated by the private space industry, these companies must also develop rescue capabilities, albeit with the support of regulatory and governmental environments. However, the discussion remains silent. Inevitably, there are many aspects to addressing these gaps in space rescue operations, and this topic can be divided into many categories. The main category, and perhaps the easiest to achieve at present, is to return to the previous methods, having an additional rocket and spacecraft on or near the launch pad for deployment as a lifeboat. However, other widely discussed recommendations can be implemented now, including having standardized docking ports. Boeing Starliner and Lockheed Martin's Orion spacecraft comply with the ISS International Docking System standard, operating under a 2-stage process, including soft and hard capture, allowing for docking and berthing. The IDSS docking interface is completely gender neutral, meaning the configuration can dock with an identical configuration. However, while SpaceX's Crew Dragon clearly docks with the ISS, the company has developed its own docking standard. Pena argues that all spacecraft must be compatible with existing IDSS. Furthermore, Cates adds in his report, theoretically, all ISS spacecraft can dock with each other, but there's still debate about whether the systems being used are completely gender neutral. Cates argues that all future space stations, commercial or otherwise, must adhere to the same connection standards, allowing any spacecraft to be easily used as a lifeboat if they need it. Currently, even if a backup vehicle is ready to deploy, without an international connection standard, the spacecraft is almost useless if it can't connect to the stranded module. Furthermore, he suggests that this approach can be easily integrated into all spacecraft if the companies developing them are obligated to comply with IDSS. And that's it for today's episode. Thanks for watching and see you next time.